Okay, so let's use what we learned about polynomials to solve polynomial inequalities. So here we're solving a polynomial equation, and we would factor and then we can graph this looking at the x-intercepts. Today we're going to look at this, and we want to be careful that we don't oversimplify it like that. So if I oversimplified it, then I would say something like this. This is wrong. We can't do that. And we have to do it like this. Let's see. Let's find out when it does equal 0. And so that's going to be at x equals -2 and -1. We sketch the graph. -2, -1. It's opening upward because it's positive. So we have this. If we're just graphing this and we're ignoring that for now, we would have a parabola that goes like that. And then we want to know when is the parabola greater than 0. So we look at the y values of the parabola. Here they are greater than 0, less than 0, greater than 0. So the greater than 0 starts here and goes to the left. So we could say closed circle going to the left. Here we have closed circle going to the right. And then we want all these x values and all these x values. And then we just say -infinity to -2. And then -1 to infinity. So I put a closed circle. It should be an open circle there. And that's because of there is no equality. It's only greater than 0. It can't be equal to 0. So that means we're going to use parentheses there. Okay. So let's try that one. And we're going to do use the strategies that we have for polynomials. And here's what we'll think of. Let's graph this. If we graph this, then we just look at where is the graph below the x-axis. So now we look at our strategies for this. And we can't factor, so we look at Descartes' rule of signs. 1, we go positive to negative, negative, positive. We have 2 sign changes. So that means we have on the positive zeros, we have 2 or 0. And then over here we put in a negative. And that'll be a positive, so that stays negative. That'll be a positive. And we count the sign changes there. There's only 1. So we have negative zeros will be 1. Okay, let's look at the possible rational zeros, and that's p over q. So p comes from the 12. 1, 2, 3, 4, 6, 12. And the q comes from the 2. 1 or 2, and then we just do P over Q. We'll have all of these numbers divided by these numbers, and we won't list them all just to save time. So let's start looking for the zeros. So we take the coefficients, and to save time, let's try 1/2. So we add and multiply, add and multiply, multiply. Now we have 3 coefficients, so that means we have quadratic, and we have to factor that. So there's one of the zeros, and we want to find the remaining zeros from this. We can find out the zeros here. Let's divide everything by 2. And then we can factor that. And we get 6 and -2. So we have 6, -2, and 1/2. We have 3 zeros, and it's third degree, so we know we found all of them. And then let's look at the graph. So we know there's a 0 at 6, a 0 at -2, and a 0 at 1/2. And then we'll check the end behavior. So that's going to be positive, means up to the right. And we have an odd degree, so it's going to go opposite direction. That means it's going to go down here. And we have, they're all odd multiplicity. So we know it's going to cross the x-axis, cross, cross, cross. And then we just check for when is the graph below or on the x-axis, when the y equals 0. All right, it's below, it's above, it's below, it's above. So we want to have from -2 to infinity, and then we want from 0 to 6. The question is, do we use parentheses or brackets? Since it can be equal to 0, the y value can equal 0, that means when the y value is 0, the x is -2, so we include that. And we include, oh, it's not 0, 1/2 to 6. So we get to include the 1/2 and the 6. Okay, and we have a 1/2, 6, and -2. All right, and so you try this one, pause the video. Before you get started, I'll just make sure that you subtract 4x and add 8. 8x plus 8. All right, so pause and try that one. So let's think of the graph of the left side of the equation. It's just a quadratic, so we don't need to do all the extra analysis. We can just find out the x-intercepts. Let's divide everything by 2 and factor. All right, so we do square root of both sides. And we get x equals -2. But remember, it has even multiplicity, and we'll have we don't need to worry about multiplicity because we know it's a parabola, and we're talking about this with a positive coefficient. So the parabola goes like this. We want to know when is the graph above or on the x-axis, and it's above, it's on, and it's above. So this is true for all real numbers. Okay, pause and try that one. And if you don't see a way to factor, then we'll look at Descartes' rule of signs: positive to negative, negative to positive, positive to positive. So we'll have 2 or 0 positive zeros. Let's look at the negative. And we're going to have a negative, positive times a negative, negative, positive, and we'll have 1, -0. All right, and let's look for the possible rational zeros, and that's P over Q. P comes from 36, and we'll go 1, 2, 3, 4, 6, 12, 36, and I forgot 9 is in there too. Q, the factors of 5, and then we'll have all of these numbers. That's a 36. All of these numbers over 1, and then all of these numbers over 5. All right, so let's start trying some zeros, some possible zeros. Let's try 3. Oops, that's -28. All right, so that worked, and we have 3 coefficients. That means it's a quadratic, and we don't have to keep guessing and doing synthetic division. We want to know when that equals 0, and it factors to, let's go ahead and review how to factor that. 5 times -12 negative 28, and we'll get multiplies to get that. We'll have can't think of what that's going to be. So we'll skip that, and we're going to go to that's how it factors. 2 times negative 6 is negative 12. X times 5x, 5x squared. And we get 2 and negative 30, so we get negative 28. So x equals negative 2/5, and x equals 6. Okay, and then we'll check the graph. 0, we have 6, negative 2/5, and 3. 0, 3, 6, negative 2/5, and we look at the end behavior. It is up to the right and opposite directions. Up to the right, opposite directions. They all have multiplicity, they all have odd multiplicity, so it's going to go cross on all of them. And we want to know when it is above the x-axis. When is the y value positive? The y value is positive, and the y value is positive. The y value is negative. We don't want negatives. So it's positive between negative 2/5 and 3. And then it's positive from 6 to infinity. Should we use parentheses or brackets here? We have to look back up here. And it cannot be equal to 0, so it's going to be parentheses. Okay, and let's check. Go ahead and before you do this one, and maybe the y is going to confuse you, and you could think of it as this. If you would just, in order to graph it, you could think of it like this. And then that'll be easy to graph. But then at the end you need to say what y is. You don't talk about what x is. So graph this and pause and then graph this. Go ahead. All right. Well, we already have it factored. So now we can think of the zeros are 5, negative 1, and 3/4. Those are zeros. Then we look for the multiplicity is even, odd, and even. And then we look for the behavior is on an even multiplicity. It turns, odd, cross, even, turn. So that'll help us graph. And we're going to go to 5 and negative 1 and 3/4. Positive 3/4. Look at the end behavior. The end behavior is 4, is from the degree, which is 4, 5, 6, 7. We have a 7th degree, that's odd, so it's going to go up to the right. It is up to the right because we have positive, 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 so that means we're going up to the right. It's an odd degree, so we're going opposite directions. And let's just follow this. At negative 1, it's going to cross. cross. At 3/4 it turns, turn, and then at 5 it turns. And now we just have to look at where's the graph above 0. Where's the y value above 0? Positive y value, positive y value, positive y value. And we're starting at -1. Should we include -1? Well, this says it's okay to equal 0. So there at x equals -1, the y value is 0, so we include it. And we can include all of these points, and that means we can just go all the way to infinity instead of breaking it up. One more. And on that last one, remember we changed it to an x, and let's just make sure we say that these are all y values because the equation had a y to start with. So we'll say y goes from -1 to infinity. Okay, pause and try that one. So let's see how many zeros, how many positive zeros. We go positive to negative, to negative, to positive, to positive. So 2 or 0 positive zeros. That's Descartes' rule of signs. And then let's check the negatives. 2 negative x. All right, and we'll have positive. This will be a negative times a negative. This will be a positive times a negative. That's a negative. So we go positive to positive to negative to negative to positive. So we have 2 or 0 negative zeros. P comes from 36. So we have 1, 2, 3, 4, 6, 9, etc. Q comes from 2. So we're going to have 1, 2. And then P over Q is all of these over 1, all of these over 2. And let's try some. Okay, so we take the coefficients 2, -9, -29, 60, 36. And let's try 6. All right, we know that 6 is a 0, and here is the quotient, the coefficients of the quotient. It's not quadratic, it's cubic because we have a fourth term here, so we have to keep guessing and doing synthetic division. We could just add on there. Let's try -3. So we add, multiply, add, multiply. Okay, -3 is a 0. And now we're down to a quadratic, so we don't keep doing synthetic division. And we're going to factor that. Maybe I can do this now without such big numbers. And we're going to go 1 times 4 to get that. It has to add to get -3. So we'll do that. and then we'd go 2x squared minus 2. So the first and the last, and then negative 4x and x. Factor out this way. And so that gives us, from here we get x minus 2, 2x plus 1. And so this gives us a 0 of 2. And this gives us a 0 of negative 1/2. 0, 0, 0, 0. And now we can sketch that. We have a 0, an x-intercept at 2, an x-intercept at negative 1/2, at negative 3, and at 6. Then we have to look at the end behavior. The end behavior, we have positive, so it goes up to the right, same direction. Up to the right, same direction. And we don't have repeated zeros, so all the multiplicities are odd, and that means it's going to cross at each one. And we're looking for where is the graph above the x-axis. It cannot be on the x-axis. It cannot be equal to 0. So that means we're looking for positive, 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 and this is going to be negative infinity to negative 3, not including negative 3. And then we'll go from negative 1/2 to 2, and from 6 to infinity. All right. And that'll do it for today.